The dark corridors and cavernous expanse are the perfect home here at the Louisville Mega Cavern for DARPA's Subterranean Challenge, the final event. Now let's bring you right on inside to our broadcast location. Hello everyone, I'm Cameron Irwin, your host, and alongside me to get through this entire challenge, Dr. Julia Badger, our technical commentator. Now let's tell you a little bit about how the Subterranean Challenge works and what the mission is, because it is incredible. The mission, we're bringing together a ton of people from all over the world to compete and collaborate, building autonomous systems in underground environments like tunnel, cave, and urban. And the purpose, well, it's to build these systems to better aid and support our warfighters and first responders. Now let's take a look at what we'll be seeing through our coverage. We are now into day number 3, so you've already seen plenty of action take place through some highlights. But this morning, we're going to focus again still on that virtual competition, and then we will head into systems competition highlights later on in the afternoon. Now you might be wondering how exactly this challenge works. Well, here's how it goes.
Here's how to win an event in the DARPA Subterranean Challenge. Find the most artifacts in the shortest amount of time. When, or if, a team's system locates an artifact, it has to report not only the type of artifact, but also its spatially referenced location to an accuracy within 5 meters. A valid report earns 1 point, but teams are granted only a limited number of reports, so they can't just guess until they get lucky. Sounds easy enough? Think again. Teams have to send their systems through dynamic terrain, over, under, and around obstacles, in austere navigation conditions, pushing the limits of their endurance, and in conditions degrading sensing capabilities and severely constraining communications. So teams need to be agile, adaptive, and accurate if they want to emerge victorious in the Sub-T Challenge.
Now they mentioned the artifacts. Here's the artifacts in the virtual world as well as in the systems. Take a look at that preliminary round. That already took place for the virtual competition. There were 6 artifact types, and then they got into the prize round. It's important to note that those are 4 additional artifacts, so all those you're seeing on screen now are a part of the prize round in the virtual world. It's also important to note 3 runs for every single one of our teams on 8 different worlds. Every single point you score matters for your team total. That will tell us who might win that glory of winning a DARPA challenge. And hey, between virtual and systems, we've got $5 million up for grabs. So let's talk about who is competing now in the virtual competition. We've got 9 different teams, and you can see all the names on the screen. Over 11 different countries represented throughout the DARPA Subterranean Challenge, and you can see whether they're university teams or in the private sector. Fantastic to have everyone come together for the Sub-T Challenge. I mentioned the worlds. Well, yesterday we got a chance to cover 3 of our worlds. Today we're going through 4 additional, and each of these can either represent the tunnel, the cave, or the urban circuits. It's also important to note there could be some crossover in some of these as well. Some fun things to look forward to. So also important, let's get into some insights, because I know you are so thrilled. We went through so much of the virtual yesterday. I mean, what did we learn and what can we expect heading into today?
We really talked a lot about autonomy yesterday and all those different strategies. Now we've got worlds that are kind of meshed together from things they've seen and putting together everything that they know. And so the autonomy is going to be really important. We're going to talk a lot about perception and how they're identifying those artifacts as well. So it's a pretty exciting day.
Well, and you bring up a great point, right? We've talked about it yesterday, how the virtual competition, it's really challenging. It's true autonomy. Once you submit your solutions, you're completely hands-off. You have to feel almost a little bit helpless at that point.
Oh, absolutely. It's one of those things, these robots, even if they're virtual, they're babies, right? Yeah. So you're letting them out into the world, and it's part of what they have been putting in all of their work too. And so it's a really exciting thing to get to see the fruits of their labor on this.
All right, well, let's see the fruits of their labor. Let's head on in to world number 4. And here's a look at world number 4, Blast from the Past. And again, this is an overview of what the circuit will actually look like. And it's actually a combination of 2 tunnel circuit courses from the systems competition merged into one, and actually back from the NIOSH mine as well, Julia.
So this is a
long straightaway, and as well as the kind of grid-like structure where you have all the frontiers. And so with the frontiers, obviously, that has one different type of way to explore.
Yep, I was going to say I'm not hearing her mic. I wasn't sure if it was just... Something we've talked so much about is how reality leads to virtual, which leads right on back to reality. So here's more on that.
Having this close integration between virtual and real systems
Let's head on in and pick up some highlights as we take a look at Team Columbia. They're going to be the first team we dig into. You can see their robot models down below. If you were with us yesterday, you also got a chance to get introduced to Team Columbia. So 3 UGVs and 3 UAVs. Those are those drones. So here is your first highlight for Team Columbia. That's actually going to be our first and only for the day. We just started off their run. That countdown clock, that's the 60-minute run for this world. They're going to start off with their UAVs heading on in. What do we know about them, Julia?
So these robots are all kind of trained with different cost functions to be able to do their trajectory generation. So they are trying to make sure that they don't go in the same spots and they explore different things. But even when you kind of do that, you still get into tricky situations that might bring your robots together or get them stuck in these different places. You see here, this is probably a place where the cost function said, hey, I'm not going to get into something that's too narrow. And so the UAV is essentially trying and not succeeding in getting through this doorway.
Yeah, you can see a little bit of a constrained passageway there. And this is also maybe a bit of a crossover, right? We've seen that with so many of those worlds as well, where those subterraneans, those kind of change as they go. So here's a look at the scorecard for Team Columbia based off of this, their best run on this world. So you can see those artifacts scored 0 there. So they look to get a little bit more improvement as they head into other worlds. Now let's take you on over to Flying Fishes, the next team. 2 UGVs and 5 UAVs. We have seen 4 different teams in the virtual competition have the same robot roster, and I believe this is one of those teams. So let's see what they were able to put together on world number 4. This is Flying Fishes. So they're going to go through a constrained passageway, already 30 minutes in, and you can see some of those graphics on the side as well. You've got the map on the lower right-hand side. The total attempts, that's 6 out of 25 for artifact reports as this UGV approaches a UAV.
Yeah, you'll see here that there's been breadcrumbs dropped along the way. And the terrain that it's going over is really very tricky. And it's one of those things where having that communication and being able to communicate back is very important, and knowing that, hey, something's been here before, I know I can get through here. But you see that breadcrumb drop right next to the other breadcrumb. Some of our teams are pretty smart about how they do it. Some just do it based on distance or time, and you can see that this is probably one of those teams.
Well, and that's a really good point too. So whether it's a distance traveled by the UGV as it drops another there, but one of the interesting things too, you can see these offshoots, these alcoves into the side, and this UGV actually missed an artifact So making sure you got to kind of find a way to get into those alcoves. Very, very important as we head on into our second highlight for flying fitches. This is going to be a UAV, and it's actually going to do a little bit of rotating here.
Yeah, the cameras that you have on board they only have a specific field of view, right? And so you're going to want to use those cameras, particularly in how they're using their perception is through those red, green, blue RGB cameras that they have. And so they're basically looking around and seeing if they can find anything. As they spin like that, it makes them able to look while they're traversing, and so that saves some of the time.
Well, that's a really good point. It's about maximizing the viewpoints, right? And all the information you can gain. There's that constrained passageway yet again, 24 minutes left in this run. Another fun thing to watch is that upper right hand, that artifact, distance from artifact, very neat. And here is your overview for world number 4, Blast from the Past. And if you look to the lower left, you can start to see that orange path start to highlight, and that is the path of their systems as they traverse through. We'll see how far they can actually get. And Julia, what do you see from this overview?
And so you can tell that as they're going down that straight path, there was some reason that they decided they really needed to hit that frontier that was to the right there. And instead of going straight back, maybe it was terrain, maybe it was just part of what they were making, right turns, those sorts of things. But for whatever reason, it got them kind of stuck. And so they didn't get a whole lot into this, and really getting longer and deeper into these caves is the way you win it. It's where the artifacts are. So.
That's where you're absolutely right. Speaking of those artifacts, those are those blue dots you see on that overlay. So here's Flying Fitch's best score. They have three different runs on every single world. So in their best run, they were able to find just one artifact. There's their success rate and the total map coverage. So that's how far they were able to cover in terms of world number 4. So moving on, let's see who's up next. How about Team Marble? We got to know this team yesterday as well. 3 UGVs, 2 UAVs, and we're seeing that different multi-rotor than we've seen from some other teams. So here's their Husky UGV driving through. You can see already one of those dynamic obstacles, that rockfall right in front.
Yeah, as you see the Husky approach the rockfall, it's going to decide on traversability. So what that means is how easy is it for me to get through this terrain? Your UGVs obviously have a different traversability than a UAV. And the Husky here looks at those rocks and says, nope, not gonna even bother. Turns around to try someplace else.
I mean, what are some of the things it's kind of, thinking through in order to make that decision? Because I know there's a lot of planners that go into these systems.
Yeah, absolutely. It's just a cost function essentially. As they're looking in front of them, they use this octo map, which is, we talked about the voxels yesterday. It's a different kind of way to essentially put a graph on your surroundings and then add things to that graph depending on how rough or elevation changes in the terrain, whatever. And as you get higher in that octomap quadrant, that reduces the traversability. So it just decides, nope, gonna try again.
I love it. Let's take a look at their next highlight. See what that octomap maybe can put together here now, which is 35 minutes left.
Yep, so this is a similar kind of thing as you're gonna look. It's trying to avoid some of the places in this path that are a little rougher. Drops its breadcrumb and then it'll keep going on. It'll get to a point probably that it has a lot harder time of traversing, but it's still gonna decide to do it. The reason that you can do that, and the nice thing about that is we talked about the cost functions, right? If you have a cost function that says, well, I'm gonna try to be as traversable as possible, at some point you might just not have that option and you have to go explore. That's your job, right? And so then you that wins out, and so you can move through some of the rougher terrain that way.
It's almost a little bit of like the risk reward, right? Those are the
exactly
things it's thinking about as it goes through these, just to put in a little bit of simpler terms for my brain.
You got it.
Julie is here for all the expertise. I love it. All right, let's take a look at what's up next. This is going to be the overview for Team Marble, and you can already see everyone kind of scores that first one. Those blue dots, again, are the artifacts on course. So once they find one, it will change color, and you can already see that UGV. Wow, it's going deep, and then those robots just following behind, and they're doing actually a really nice job finding those alcoves.
Yeah, you've noticed that they kind of branch off, and some of them go down and check those frontiers, and so their overall autonomy and how they're coordinating their robots with each other is allowing them to do that. They have this shared map that they communicate, essentially, and so they know, hey, this has been explored, let me try this other frontier.
So now let's take a look at how they finished up on Blast from the Past on their best run. Here are the artifacts. Scored 0, success rate 0, 13% map coverage. So even though they were passing those artifacts and potentially were exploring areas in which they could be found, they were not able to successfully report back. Now on to Sodium 24 Robotics. Just a one-man team. He's got 3 tracked UGVs and 3 multi-rotors. And he's using that HD2. And that's the first one you're gonna see as that breadcrumb is dropped just beneath. He's got a rotating gimbal up top. That's the payload. That's where a lot of those sensors are going to be found. You can see one of those blocked passageways. And this team really focused on communications.
Yeah, absolutely. Each one of these robots have a set number of breadcrumbs that they can drop. There's only so much that you can do, and so it's better to be smart, right, about what you're doing with those limited resources. Again, going deep into this cave is really important. You've got the long straightaway and then all of the hashes and frontiers. You want to make sure that your network is doing the right thing. So some of these have 12, I think, breadcrumbs to drop. So what's the optimal way to do that when you have so many frontiers to look at?
And is 12 the typical number you'd see, or does that kind of change for each?
I think it changes for each, just depending on your robot.
I understand. So moving on to our next highlight, another from Sodium 24 Robotics, 6 active robots on course, another breadcrumb drop just 9 minutes into the run. There again is that artifact distance. So they got some work to do before finding it. It looks like there actually might be one of those fire extinguishers just behind them.
Yeah, absolutely. They're walking or rolling into this more rough terrain and trying to find their way around. You kind of see that as they're moving, looking back and forth, both on the payload on top, you see that rotating around, but you also see the tracks themselves doing that. So it's either they're getting some interesting feedback on their sensors, or that's just how they've decided to navigate this path to aid their perception.
So while that system continues to search, we're going to move on to another system. Again, these are highlights. So we're taking looks back, already 9 attempts now, 40. There's that local rockfall again, just out in front. This UAV, well, it might be able to pass that. We'll have to find out. But this is a team that has updated cost functions, and as it continues to move through, they're kind of updating the map to be able to have the adaptability.
Absolutely. The Sodium 24 team, again, you talked about the comms. One of the important things about that is you do have a limited resource of your breadcrumbs, but also bandwidth, which is the size of the pipe that you can send your data back over. And so when you have that limited bandwidth, you need to make sure that you're passing the correct information back. And so being able to have the shared map and update it locally is very important, and then send that information back to your UGVs who won't even bother trying to go through that path.
So let's take a look now at how Sodium 24 Robotics was able to get through Blast from the Past. Again, trying to go down that right path, that first alcove. And they're gonna go the distance yet again, all the way down, and much quicker than we've seen some other teams. And there are 2 correctly identified artifacts, and they're motoring. I know you love speed.
We've determined that, haven't we? Yeah, I know the good perception that they were able to do got them their points there.
Speaking of points, well, they were able to pick up 4. There's the success rate, 16%, and map coverage, 21% off their best run. Team Barks up next. 2 UGVs, 5 UAVs. This is a team that has done very, very well in each of our virtual competitions, actually picking up one of those top spots in our subdomains. And here's Team Barks, a UAV flying through, and one of the dynamic obstacles too is fog, which I believe this UAV is going to have to encounter here in a little bit. But what are some of the challenges? I know we talked about it yesterday, but that fog can really pose some problems.
Right, and I think Team Barks has done a nice job explaining kind of how they've gone about this. They have these what they call local continuity filter. What does that mean? You have this array of points. You can kind of see of it as a grid of points that their LiDAR sensor that's on top there, that's sending out light and coming back with that light and just deciding what the distance is. When you've got fog, you basically have particulates that are out there that are interrupting that flow. And so instead of seeing the wall that's a meter away from you, you're now seeing this little point that's like only, a few centimeters from you. And so you have to get over that essentially as a robot, right? You have to filter that out. And so they've done basically that. They've been able to say, okay, most of my points are on this wall. I'm going to ignore the fog, and it helps them get through.
Well, and that's just another great example as we take a look of another highlight from Team Barks, but another great example of the virtual to reality, fog being such a thing that you can 100% kind of to expect in some of these underground environments. And here again is a UAV. It's in a little bit of a different part of the course, and you can already just start to see whether it's the expanse or the constrained passageways. Now there's pillars in front of it, and it's also important to note those anchors on the side, those look a lot like vents. They have to be able to decipher those, which is one of our artifacts.
Absolutely. So they're using, their perception that they want to look at things and make sure that they are not missing these artifacts. There's so many that look very similar. They have to go and make sure they get enough glimpses of these to be able to filter them out from their perception filters and those sorts of things.
So you've got to be able to find the right artifact, identify it, and it has to be within 5 meters of an accurate location, also important to note, and correctly identified in order to score one of those points using your artifact reports. Again, that's on the left side. You got 25 per run to be able to figure out what exactly those are. So moving on, this is another UAV, Barks, and it's going through, yet again, another constrained passageways, several intersections, and let's see if they can put some points on the board. This is just 4 minutes left in their run, and so far they've only used one of those attempts.
Yeah, there's definitely, they only do things quickly at just the very beginning, and then they kind of hold it back, that robot base that we talked about. But we're seeing here near the end, you're going to see a lot of the different points kind of add up because they are close to the end. The robot base is getting the information from everything and determining, basically filtering it all together, saying what's my error, what's good, what's happening with everything, and deciding what are the good ones to go. You see not all of them score, but 8 points, that's pretty good.
That's pretty good. And here you can look at a time lapse of how these systems, again, travel throughout this same course, Blast from the Past. There's very quick movement all the way, just within 7 minutes, all the way to the end of that constrained passageway. And then again, by 9 minutes, they've even made it to an area we hadn't seen any other teams really make it to in terms of our coverage, all the way back around. The depth really on display.
And you don't see the score ticking up here just because of exactly what we just said, where it's holding it back. But the score at the end, it's obvious that they've spent a lot of time going and finding different things, and that really helps them move up their score. If you just stay in that first one, you only get, 3 or 4 points,
So Barks, we noted, especially at the end, there's those 9 points. Artifacts scored from their best run, success rate 36%, and wow, 50% map coverage. Incredible job by Team Barks. And now it's time to take a look at our scorecards all combined into one so that you can see in terms of total teams and how they all shaped up, and a little bit more of a head-to-head method. 9 for Robotica, 9 again, very solid runs from those top 3 teams. What else are you seeing, Julia?
You can tell this one's a little harder. So there was definitely higher scores that you saw yesterday on the runs. This one was kind of a combination of 2 of the 4 formats that we saw yesterday, right? We've got the long straightaways, we've got the hashes. Made it a lot harder to get those spread out artifacts.
So let's see now what our teams were able to do in terms of all 3 of their runs just on world number 4. So let me explain it out a bit. Coordinator Robotics scored 23 total points from world number 4. That will ultimately head into their total combined over the 8, but we're going to get to those numbers later on. So again, here's Robotica, 20 total for them, Barks 19. Team Columbia still looking to pick up their first point, or excuse me, they were not able to pick up any points here in world number 4, but I'm sure they did in some of those other worlds. Something we've talked so much about is how reality leads to virtual, which leads right on back to reality. So here's more on that.
Having this close integration between virtual and real systems was part of the Sub-T challenge from the genesis.
It was an idea when they first came up with the virtual competition and systems competition kind of going parallel, but then we also throughout the challenge have tried to weave them together so they're not just running side by side, they're actually feeding into each other and both contributing to the other.
Testing in the real world is a really hard proposition. The Sub-T virtual testbed is the one-stop shop for being able to develop and design in a virtual setting. The Sub-T virtual testbed comprises a couple of key tools. The first is the Sub-T simulator. This is that next-generation physics-enabled simulator, allows for realistic exploration of autonomy and perception in complex underground simulated environments.
We've seen teams use the virtual testbed in a lot of different ways. We've seen virtual teams obviously developing their software solutions for navigating using the robots. We've seen teams in the systems side actually go out and scan environments and then try to model them in the virtual testbed.
The next tool in the Sub-T virtual testbed is the tech repo. This is the repository that houses all the different virtual robot models that one can use to pick and choose, mix and match to compose the best possible team to deliver the capabilities of interest in the Sub-T challenge.
You can kind of control each little component individually, whereas in the real world, you may not be able to do that.
And to wrap all of that together is the Sub-T virtual portal. This is the way in which competitors can submit their solutions to our cloud-based simulation and allow for them to develop and test and compete in that virtual setting. What the virtual environment allows us to do is explore the what-if scenarios and how do your solutions handle that uncertainty, that unknown environment. And that level of, that single advantage of being a little bit better prepared for that real-world operation might be the difference.
The entire Sub-T tech repo and the Sub-T virtual testbed are open source and will continue to be open source past the challenge. And anyone who wants to submit a new robot model can still do so. We still have some open robot model submissions that may be incorporated past the final event, submissions from external engagement outside of the Sub-T challenge, which is fantastic.
Now, throughout the entire Sub-T challenge, they've continued to really improve upon that virtual testbed. And what are some of the ways in which we've seen that take place?
Well, so when they first started this, they didn't have as many places where they could add the uncertainty. And so one of the things that came up in some of the narratives that the teams came back with was that IMUs, for example, our inertial measurement units, had a constant bias in the last event. And this event, as they upgraded their simulation to be closer to reality, to get the virtual closer to reality, they made a non-constant bias. So it means that they had to update all of their filters. Everything that used that IMU now had to go and think about, okay, now it's not as trustworthy. Just like in the real world, it wouldn't be as trustworthy. So they are trying to make things from the virtual to be more like reality, so then it helps the actual systems as well.
Well, and we've seen this continuance, this merging between reality and virtual and systems competitions, but it's also, there's a lot of collaboration that's taken place even across teams. And so let's take a look at some of those systems that maybe have been modeled by one team or made by one team, modeled by another. And here's a look at one of those. This is Spot, and actually this is from Team CoStar, but we've seen other teams also utilizing it.
A lot of people have the spots, and I think that the one team that modeled this and put that in there it was really important for everybody else. Then they were able to use it. It's kind of the open source community that robotics actually is very good at, and I like to see people being able to build on everybody else's work.
Absolutely. You talk about open source. This is another one of those systems. The DTR has also come up. It's developed and tracked vehicle by Cyro Data 61, but it's also being used by CTU Cras Norlab in the virtual competition.
One of the things I really like about this one is that they have their LiDAR, the main navigation sensor, off-axis, spinning a little bit differently so that it can get a different swath of basically all of the terrain around it. And I think that might be something that's appealing to some of our other teams.
You got to figure out those angles, right?
Right.
See all of your area around you. Now this next one is PAM. It's a UAV developed by Coordinated Robotics, but it's also being used by Robotica in this virtual competition.
The PAM is fast. It's the second fastest UAV that they have in this virtual track. What's interesting to me about it is it doesn't have a payload of a LiDAR like some of those, and so it's interesting that they have the other sensors like CO2 and thermal on there, so definitely a reason to pick it.
All right, well, let's take a look. It's time to finally head back into our worlds. We're going to give you a quick overview of world number 5. This is Gamma, and it's supposed to represent one of those urban worlds, and it's actually based on 2 systems competitions combined into one from the urban circuit. And that's, again, if you think back to urban, it was those alpha and beta courses merged together.
So this is interesting because you see that there's essentially at least 2 stories. There's a lot of vertical shafts, some staircases, those sorts of things, and it's harder to kind of see on this map, but you'll see that the artifacts are on these different levels, and so it's really important to fully utilize your team so that you're covering the entire space.
Well, and we've seen different robot rosters, you know, throughout the virtual competition and even in the systems competition. So really being able to expand deep using every single model that you have and deploying them in the right strategy. You can see the challenges presented in this world, from all the stairs. There's a little bit of rail. It's this crossover too that's really incredible about this.
Yeah, absolutely. And I love the urban environments because there's just so many places that you're going to see those, and it's a really important thing for us to learn how to navigate because not all buildings are created the same way, right?
Well, and it's interesting too, we heard from so many of the teams saying, hey, it's so much more angular in the urban environment compared to that cave. So here's a look at our scorecard on number 5. Again, that's World Gamma. Barks up at the top, CTU Crest Norlab. What else are you seeing?
Map coverage is pretty good. You get up to about a quarter of the map on some of the teams, and so that's obviously indicating that you were able to go up and down. The spread of the points is about what we've seen, and again, like World 4 that we just saw, there's just not as high scores as we really have seen yesterday.
Oh yeah, so that blast from the past, that was definitely a tough course to have to handle. So let's take a look at our leaderboard just for world number 5 alone. This is Gamma. Again, there's Barks at the top, a very solid team. 24 at the top. There's a little bit of a range there to number 2 with CTU Cross Norlab. Columbia, again, not able to pick up a point yet. However, you know, we'll see what they can do. We'll see that cumulative score at the end of our virtual. So let's move on to our next overview, world number 6, lanternfish. And clearly it's pretty obvious what kind of world this could be.
It's definitely a cave, and I think that the game designers were somewhat merciful in the fact that they left all the artifacts kind of closer clumped to the beginning, because this one's crazy. The elevation changes, the terrain that you can even see just from looking at this, it's very interesting. It looks like also that they were able to kind of put this cave together from different caves, and you can definitely tell that they picked the hardest parts of each of those caves to kind of merge together.
You know, some of the things you will see, tight passages, that's definitely going to come up. Barely big enough, honestly, for a UAV to be able to traverse through, and a lot of long cave tubes, large caverns, and you mentioned that there's different types of environments, and I think that's really speaks true to what DARPA has researched in terms of going out and checking out some of these locations. They said no one environment is the same to the other in the cave world.
Yeah, they knew that everybody had these cost functions and different optimization parameters, and they said, how do we screw them up with something that's going to make that push? And that's awesome, though. Really, that makes you drive to trying to be more adaptable, more autonomous.
Absolutely, adaptability, again, always so critical. So that's lanternfish, just an overview. Let's take a look at how our teams did. Scorecard coming up quickly. And again, we kind of see those same 3 just at the top. Dynamo in at that number 4 spot, but look at that percentage. Success rate for Barks, 100%, 64% for Dynamo.
Yeah, I'm looking more at the map coverage. It's down to like 6, 5, 4%, and we still scored a lot. This is what I was talking about those merciful game designers, and that we still were able to score even not making it too far into that cave.
I think virtual competition lead Angela Mayo would thoroughly enjoy that remark as we take a look at our leaderboard. Coordinated Robotics finishing in the top spot on this world. Lanternfish, 14 total points, 13. A little bit closer there from 1 to 4. And there you go, Columbula getting a couple points on the board. All right, so now it's time to get into one of our favorite segments. It's time to dig deeper into robot technology. Today's conversation, well, it's regarding perception. Here you go.
Varying conditions such as low light, complete darkness, dusk, fog, mist, and smoke will actively occlude environment features and landmarks needed for systems to accurately detect artifacts and create maps. To tackle these environmental challenges, teams have outfitted their robots with onboard lighting and a suite of sensors such as with cameras, LiDAR, radar, thermal, gas, position encoders, and more. Fusing the results from each of the sensors on each of the robots enriches the robot's understanding, and thus the human supervisor's understanding of the environment. Maps developed between different robots can be compared and merged to provide new insights of the environment.
The difference between sensing and perception, I think, is the difference between facts and information. Cameras spit out bits of data. It takes an algorithm or a display or something else to make those into information. And to go further than that, I would say, if an algorithm were to perceive something, it would interpret, it would predict, it would understand that information. And sensors don't understand any of that information. They just acquire the information. You know, the military has to fight in unconstrained environments, uncertain lighting, no fixed information, right? You have to be prepared for everything. And Sub-T, to me, is possibly the most challenging autonomous environment in which to operate, because you have none of those things. You might have no light, you might have no intel, you might have completely uncertain terrain, completely uncertain obstacles. There is not a single modality that's going to be able to function adequately in those environments. So you're going to have to put all of those things together. You're going to have to be able to see if you're able to. You're going to have to be able to hear if you're able to. It'd be great if you could sense changes in the environment, right? Changes in the airflow, changes in the temperature, right? We would interpret those as meaning we needed to do something differently. How do you get a sensor to do that? And then we really need to be able to integrate those together so that a vehicle, an autonomous vehicle, can make sense out of those. This is what any robotic system, right, is going to be able to need to do. It's just that much more complicated because it's that much more uncertain, I think, in a Sub-T environment.
Methods of perception. We've seen so many different types here already in the Sub-T challenge. What are some of the ones that really stick out to you that excite you?
Well, a lot of our teams use this YOLO method to decide that there is an object right there. And in some ways, they also have the localization with that. So YOLO stands for you only look once, which is one way to say that it's fast, right? And so we are looking at a learned system. It's a convolutional neural network, which is a fancy word for something that has the ability to essentially break down a picture into structure, into data, and then find the patterns with that. So you train it with a lot of data. And then once you have that structure can go out into the field and very quickly say, okay, this is what I think it is. YOLO is nice in that it both gives you a classification, which means I can tell you what that object is, but then it also goes and says, here's a bounding box. This is where I see patterns or parts of that structure where it actually looks like, hey, it's like this, and I'm going to say that everything in that box is. So that helps you localize it. Some teams use the LiDAR, some teams use several of those boxes and triangulate to get the location. So it seems to be pretty successful from everybody who's been doing it.
All right, well, my goal is that as we go through this next world, you might point out some of those extra those moments of YOLO that we can see. All right, let's head on into world number 7, locomotive. That's a great name because, Yes, my goodness, look at the challenges already presented in this world. Vertical shafts, uneven terrain, dynamic obstacles, and then tunnel. Looks like some open spaces and cave all combined into one.
Yeah, they just mushed everything together. So we've got lots of different frontiers to go through, all the terrain, the big rooms. Those big rooms take time, and so, you know, having things in there, and there's not even that many artifacts in there, so hopefully they can go fast through those. Then there's a bunch of obstacles, a bunch of dynamic obstacles, and in kind of mainline paths. So this is definitely going to be a challenge.
Well, you talk about some of those dynamic obstacles. There's a tunnel collapse that can take place that forces robots to have to replan and find another way, and also can kind of skew what some of those communications and their ranges. You've got the fog also in play. We already mentioned the vertical shafts, and of course the uneven terrain. One of those big ones, subway rails. That is really tough for systems to have to deal with.
Absolutely, for the UGVs anyway. The UAVs seem to be just fine over that. But there are a lot of things that the UAVs have to do. There's those shafts and everything, with a lot of elevation changes in this as well. So they're going to have to work together to really explore this area so they can get around those dynamic obstacles when they happen.
5 total dynamic obstacles on this world alone. So let's dig into the first team. We will see some highlights from here. It's Team Robotica. This is one of our many international teams. 4 UGVs, 4 UAVs, and let's see what they can do here on Locomotive. Already you can see that fog that collapse just behind the UGV as it continues on. And we talked yesterday a lot about how Robotica, they kind of use that wall following technique as they deal with some of these rails.
Yeah, absolutely. It probably sensed that behind it didn't triggered that collapse, and it's going to have a really tough decision deciding, okay, do I go left, do I go right, do I go back? And so it's got to have the decision-making ability to decide what the right path is for both exploration and traversability.
So as this guy continues down the rails and figures out, well, you can't quite traverse past that, we're going to move on to our next highlight from Team Robotica. Here's a UAV, and we just talked about, you know, some of that wall following, but what's interesting is this is a team that has not used UAVs in the past, and again, they're using that wall following technique. Does it still work with UAVs, or how does that function? Is there a difference?
Well, I think one of the challenges that I would expect is that these walls aren't straight. So you're going to see that the passageway gets smaller, or you're doing more of this back and forth motion that you see because it's looking at this very textured type of wall. So you're going to see that in this part of the cave, right, but not necessarily in the other part. So being able to accommodate those different structures around you and still get through is really impressive.
A lot of diversity in this world alone. Let's see what Robotica can do in their next clip. 8 active robots. Now we're 36 minutes left, 20 meters away from the nearest artifact. And again, avoiding some dangerous scenarios here. This one, very challenging. You see 2 UGVs, and this is the dangerous scenario I'm talking about. Those stairs.
Yep, it decided, nope, I'm not going to go down there. So it has one of those pit detectors as well, and deciding that this particular UGV is not going to make that. So a UAV, obviously, would be able to decide to go. So using the teammate skills, I guess, if you will, in the multi-robot sense, to decide where and how to deploy these assets. Same thing here. Oh, good.
That makes me so nervous. You hold your breath as it gets closer. My goodness, it shifts awfully quickly. So now that we've seen some clips from Robotica, here is their path through Locomotive.
So they are going the same way, which is interesting. Probably the UAV following where those breadcrumbs get dropped. But then they get a little stuck on those paths there. Don't see a lot of action, but you do see a lot of things going back and forth. Oh, one broke free. That's good. Making it through.
What else is really interesting to me is there's multiple points of entry from that staging area, right? And so how do you choose which path to go down just based off of that initial search?
It's something that is probably hard-coded in the sense that they have these different methods to decide which way to go, or cost functions, or what have you. And so even when you see kind of run to run, it's actually probably pretty interesting to see, okay, do they always turn left? Do they always do right? Like, is it depth first, breadth first, whatever it might be. So you'll see some of those similarities just across.
So Robotica, they got awfully deep. We saw them also get into that cave area or that tunnel area as that artifact scored now up to 8 just on this world alone, 62% rate. As we move on to our next team, it's time to take a look at coordinated robotics. Again, Kevin Knadler, the head of this team, the one-man team in the virtual world. Here is his UAV going through, and again, he just continues to build upon his system. Started with UGVs, then went to UAVs, combined them at Cave, and now he's got them all together yet again here at the finals.
And what we talked about it yesterday, what I like about him is that he doesn't mind going fast. And so he's got the plan, they're constantly updating that plan. He's working on a plan that looks for what is the best path. And so you get to define what best means for you, and obviously they have, but that they are obviously wanting to go deep. And so the exploration for them is best, getting into the cave, making sure that you're covering a spot that isn't already covered by another robot.
You know, what's incredible to me is seeing the speed at which these UAVs travel and how they just continue. Even if they see something else, even if it's an artifact or a different element of the course, it just continues on. The quickness that it's able to get through these is just astonishing. As we head on to coordinated robotics, here's a look at their alley UGV, and it stays close to the wall in the cave. Let's see what might take place. We talked about 5 total dynamic obstacles here on Locomotive. There's another one, it just fell there. What else do we know about Alley? We've covered it in extents, but what else can we know?
Well, they do have an extra camera that gives them some depth perception. They use that both for perception, and I'm sure that they use it as kind of a chuck in the navigation, particularly when we get into some of these dynamic obstacles with falling rocks or fog or those sorts of things. It basically gives you another check. We've talked about LiDAR a little bit. That is the most common navigation sensor that is used, but backing that up with like an IMU or these depth sensors is always a benefit for autonomy.
Well, let's take a look at another dynamic obstacle for coordinated robotics, because you just mentioned it, the fog. And for this one in coordinated robotics, they actually encounter it twice, and they have a little bit of a different approach each time. So we're going to hang out and delay as this UAV continues through this tunnel. See if they can trigger that first dynamic obstacle.
You see that as they were going so fast, they kind of had to rear back when they decided they were going to go down. That's okay. Go fast, right?
And stop quickly.
Yeah, but that does kind of indicate that they are doing their planning kind of online. They don't stop and plan. They keep going, and if they find something better, hey, let's go back a little bit. And that just means that you've explored a little bit more in another direction.
So it's going to go up this slight incline, just 19 minutes left. They've already used 8 of those artifact reports. They have a score of 6 at this point, and it's so fun. Just continue to watch that speed on the left side of your screen, and all of a sudden, wow, it changes from tunnel back into cave, and there is that fog coming up. And the UAV going through.
Not excited about it.
How can you tell? The shimmy, the shake, is that the cue?
Definitely, yeah. It kind of reared back just a little bit and then slowed way down. We were usually up in the 2 and 3 meter per second. Now we're at a 0.5 meter per second. You know, feeling its way through. Obviously, its filters are probably getting bombarded with all of these extra particles that are hanging out in the air. But hey, it's still looking for things and moving through. So move right fast up again when we get out of there, right?
Oh yeah, so going through one patch of fog and then avoiding another. But as you take a look, coordinated robotics through this course, they decided to go with that left path out of the staging area after sweeping through. Again, you can see those blue areas. Those are the artifacts. They have yet to throw out those scores as that time continues to tick down. But quick, 10 minutes in, and they've already hit a few new places.
Absolutely. They've decided to hit different frontiers and to move forward on that. They did a great job of coordinating their individual robots to make sure that they're not doing the same thing. You see the like wiggles in the big places, and especially in the big room and then kind of down at the bottom. Those are those big caverns that you have to spend a little time looking around because you don't know where an artifact might be hidden. And it does look like they're a little bit limited just by, communication. You have to turn around at some point and go back and then report what you found.
So many different methods to reporting those artifacts. At which time do they come up? When do you send them back? How do you send them back? Well, they were able to send back a few as they picked up 12 total points on this world alone, 48% success rate. And as a reminder, they have to correctly classify that artifact as well as find its location within 5 meters. So moving on to CTU Krasnorlab out of the Czech Republic and Canada, 2 tracked UGVs and 5 multi-rotors. Let's see what they were able to come up with on locomotive. We're going to start off with a UAV. This is their quad rotor, and it actually backtracks a little bit and decides to take a different path from a UGV that's also going to come on screen as well. One of the things that is here in my notes is they talk about an autonomy stack. So explain what an autonomy stack is. I feel like it's going to have something to do with the layers that you were discussing yesterday.
Yeah, absolutely. So this is something a lot of the teams use kind of a goal-based global map. So they are looking for what is the best thing for my team to do. And in this case, the best thing for the team was to have the UAV go down passages that the UGV couldn't do. So you're going to be able to emphasize more map coverage and getting things further because the UAVs access areas that the UGVs just can't.
So 27 minutes left as we move on. We're actually going to go to a different run for CTU Krasnorlab, or an earlier point in theirs. This is 57 minutes still to go. And this is a different UGV that we've seen. There's that tracked system.
Yeah, this is the DTR with that off-axis LiDAR that they have spinning around. So it's this is nice because that will help it be able to detect this fall. Hopefully we don't see it go over the edge. I'm just teasing, I know it doesn't. But it is, that's one of the things that it allows it to do, right? It can kind of see at an angle down and it understands those elevation changes and allows the rover, the UGV, to not go into those areas.
And for CTU Krasnorlab, this is a team that joined the virtual competition just a subdomain ago back at CAVE. They finished off in that 6th place finish. They've added a few more multi-rotors to their solution since CAVE virtual competition as we head on to their next highlight.
Okay, so this is one of the teams that are using the YOLO method of detection. And so you can see that it's kind of going back and forth. It's paused just a very, very little bit as you went past the survivor artifact that we had there. And it was probably using those extra swipes to get to that triangulation of the bounding boxes that we were getting from the detection from those YOLO. So I think that's one of the ones that they scored.
Well, so far just on the board, 2 points there. Again, this is another team using one of those team bases that's hanging out in that staging area, and they spread out awfully quickly. And the speed, again, on display for CTU Krasnorlab. 7 active robots already, and that's just within 8 minutes, so an interesting deployment strategy, kind of sending them all off.
Yeah, with the battery life that you have on your UAVs, you are going to have them come back early or leave them out there, I suppose, as something to go back and get later.
Again, heading deep into that circular area. That's one of the interesting parts, just having to kind of deal with all different landscapes as you take a look at CTU Krasnorlab's artifacts. Scored 14 in world number 7. Their success rate 56% and over 76% of their map coverage. So on to our final team in the virtual competition. Hilario Tomei, 5 UAVs. It was so interesting to see this yesterday, just really focusing on exploration with the UAVs. We've got a few highlights from this team just within 5 minutes of deployment. Their UAV. not having to deal with the rails below. That's awfully helpful. A little bit of a slower speed.
Yeah, it's probably trying to figure out and go through this curved area and understand where it's going. It does use a model predictive controller, and so it basically tries to look ahead as part of this lower level control to make sure that it's doing the right thing with obstacle avoidance. But you'll see once it's a big open space, it goes a little bit faster. So we had the constrained going slower, didn't really know how much was ahead. Now it's big open space, go faster. It's one of the nice things about that method.
Well, it's so fun to see the changes and the shifts too. I mean, from one space to another, and then all of a sudden it picks up speed, understands its surroundings so well. I mean, the math, the algorithms behind all of this, it's pretty incredible. Obviously some blockage there in what appears to be a subway area. Let's take a look at another UAV highlight for Team Dynamo. They're all going to be UAV highlights as this one comes up. And you can see the varying subdomain. You start here in the subway, and there's a lot of connection points that can take place. And a great representation is you take a look at that orange arrow down on the map, and you can start to see them coming up to one of those intersection points where it's going to have to make, yet again, another decision.
You see with the blue dots there that the decision probably is pretty easy given the obstacles, unless those obstacles don't matter to the UAV. But the nice part about their algorithm is that since they have separated those layers of architecture here, the planning of which way do I go isn't really about what they're doing so much. It is more about what's the right path, kind of at that higher level of, okay, what is going to get me to my goals in a faster way. And so this online type of planning really makes you speed up. You don't have to sit there and wait and think about it and go, like we can see in so many prior robot competition.
Well, you saw the trigger just beneath there, having to make some decisions, not going to turn back around because that place is definitely blocked off. So you can see 10 total attempts of the 25 artifact reports, a good score of 7 to this point. And again, Team Dynamo using those UAVs. What in the world is in front of them? That's the question. Is that a vertical shaft?
Well, there's definitely a wall, and so how far it's willing to go and to explore to go down that vertical shaft, it really depends on how you've tuned your controllers. Clearly, they've tuned it so that it is a little more aggressive, which is definitely competitive and good to do because you want to be able to get further into the competition. So that was a good decision that they made from that cost standpoint.
Well, and it's incredible to see how smooth too, right? It just goes from one verticality all the way down and just that easy transition, just beautifully done from Team Dynamo.
Yep, definitely. It was that distinction of the layers.
And now this is something I am looking forward to because this team travels so quickly, just 4 minutes in, and watch what they can do. No attempts yet in terms of artifacts.
So one of the things that you can see from this view, which I think is interesting, because they have just those 5 UAVs and those UAVs have limited life, they have to come back and charge. It's part of the strategy, if you will, just to know how and when to deploy them. Like, okay, I'm sending this one this way, this one this way. Do I have some method that says now I go this way because I've learned this? Or what happens with those other ones? And you can kind of see that from this viewpoint, and wow, look at how much of the map that they are covering.
And even all the way around, my favorite, the roundabout.
Right. Well, and it's a big cavernous roundabout, right? So it's also about being able to kind of look throughout everything that they're seeing in that cave.
And it's also interesting, so just 30 minutes left, but they still had pretty much seen most of the map, still sending in artifact reports. They were able to find 17 artifacts in terms of point scoring, and their success rate 81%. 82 total map coverage. That's pretty incredible. So now let's take a look at another scorecard. This is going to be all our teams now head to head from this world alone. 17 for Dynamo, CTU, Krasnor Lab, and it's important to note every point matters in the virtual competition, as those will all end up into a cumulative leaderboard. But let's take a look at the leaderboard now. This is just, again, for world number 7. So Dynamo finished in that top spot with 44 total points. That's going to add on up to their total. CTU, Krasnor Lab, 36. Barks with 11. And Coordinator Robotics, nice job at that number 3 spot. So I just mentioned that cumulative leaderboard. This is where it's going to get exciting. We've made ourselves way through 7 total worlds, and where do we stand heading into that final world? Who will end up winning the DARPA challenge on the virtual competition here at the final event? Dynamo in that top spot. There's not a whole lot of space between them moving on down.
No, definitely not. It's very cool to see the spread, but it's also really cool to see how well people have done on that last challenge where that last world where everything was kind of put together. Very exciting.
And Coordinated Robotics and Barks in at 3 and 4. Those are the 2 teams that have won those virtual competitions up into this point. So we could have a new winner at the final. Who knows? It's going to all happen on the final day, that last world. And you can catch it, of course, here on Sub TV. Now, give me a couple of insights just heading into that last world. What do you expect?
Well, we definitely saw that it was a little bit harder when we started putting worlds together, but the World 7 was really great to see that we had all these different types and subdomains on there, and they were still able to really put that together. So I'm really hopeful that in World 8, when we see this, that they're going to do a really great job. We'll see a lot of points scored.
All right, well, we got to put a little bit of a pause on the virtual competition for now because it's time to head into our systems competition. Let's take a look at our schedule before we get any further, though. We've got Wednesday, Thursday, and Friday. That Friday, that's the big day. Awards will be handed out. We'll find out who's winning the money and the glory of a DARPA challenge. We'll be right back in a minute with systems competition. Hello and welcome back to DARPA Subterranean Challenge, the final event. It's time to dive deep into the systems competition. I'm your host, Cameron Irwin, and alongside me, well, we've had her the entire time, the brilliant, very brilliant, Dr. Julia Badger, our technical commentator. Now let's dig a little deeper because systems competition, we're going to be going through the preliminary round, the second run for these teams. We saw the highlights just yesterday and we've got a full day ahead. Again, these runs just 30 minutes alone. They're still searching for artifacts, and these robots, they're working a little bit autonomously as well as having some human intervention as they search through these underground environments in a single course. And what's crazy, you might hear, some of the background noise. That's because we're just alongside the entrance of the course. What are some of the expectations you have heading into this day?
Well, yesterday we saw a lot of people exploring the cave, just trying to get their bearings, understanding what it is. We've kept this secret for a long time. Today I'm really hoping to see them start to use their perception and identify some of those artifacts. We might see some more scores today.
All right, let's start looking into some of those highlights after we see our teams. We've already introduced you several times throughout this competition, but here's a look at the systems teams. We've got 4 crossovers from the virtual competition that has been happening simultaneously. So these 8 are heading in on that staging area and have to go through quite the trek to be able to potentially win the glory of the DARPA challenge. And hey, there's a pretty big prize pool, over $5 million. So let's look at our first team up. This is Coordinated Robotics. And a fun team this one is to watch because they've got not only the numerous systems down below, but they've got a little bit of a different pit crew. Kevin Knadler, the head of this team, and we have our guy, Scott Walker. He has been working with all of these teams post-run. So let's check in with Scott and Kevin.
After the second round for coordinated robotics, Kevin Knadler joins us once again. And Kevin, it did take about, 7 minutes or so to get ingress on the first of your UGVs. Joe, what was the delay?
We had a difficult start. About half of our robots were not talking on the network. And so when we can't talk to them, there's not much they can do. And then once we were talking to them, we were getting data back from them, but they wouldn't drive. And so they were just wanted to sit there today.
Well, not every one of them sat, because we did get some really interesting footage, and we'll show you some of the events of interest from, this is what your first robot in, Joe, today, and we can see some of the communication nodes was at the strategy here going forward.
Yeah, that was one of the things, that's one of the things we're happy with. Joe was able to drop communication nodes as it went. When the wireless comms got bad, it dropped the nodes and moved on, and so we were able to drive Joe in there quite a ways. I saw several artifacts, and so we're happy with that portion of the run.
Good, and now it's in the cave section of this subdomain. So, and you can see the mobility now. This is a situation where we thought it was going to get stuck here, but managed to get its way out of it. Did you notice anything about the mobility there?
We're pretty happy with these. They're very bottom heavy. Most of the weight is in the wheels there, and so you can run them into things, run them over things, and they don't tend to tip over. And so it just goes.
But this is where we get to Alley, actually. So the second of your UGVs, and this is really meant for what? The fiber optics for communication?
Yeah, we wanted to be able to deploy the fiber optics. We ran into 2 issues with that. We weren't talking over the fiber optics, and then the reel here, you can see the fiber actually got stuck and was trying to pull the whole base station in with it. And so we didn't want that, so we disconnected it and let it run without the fiber.
Okay, so that was the disconnection that we were seeing.
Yeah.
Okay. There was a backpack we saw, and it was unable to localize that artifact?
Yeah, the robot says it's at 0-0, even right here. It's clear back at the base, but the good thing is it saw the backpack, identified it correctly, but it said it was back at the home, so we had to sort of just guess its location on this particular time.
Okay, and this is the third UGV you got in with that marsupial configuration into the tunnel area. And then Karen got in as well, one of your largest bots near the end. Were you able to get anything from this run?
No, that was more just a test. I wanted to drive over that node. You saw it drive over that. Make sure that nothing happened and see how well that vehicle would drive and fit in this terrain. And so it was good to get in there and do that particular test, so we were happy with that.
So all told, over these last 2 runs, have you gotten enough between the 2 that you can knit together going into the prize round?
I hope so. No, there's a lot of lessons we've learned, a lot of issues. We thought we had a number of them fixed for today, but clearly we have a lot more work to do before we're ready for tomorrow.
Okay, well, we'll look forward to the prize round coming up for coordinated robotics. The scorecard now for the team. Thus far today, we saw that 1 artifact. Low success rate, but a lot of sectors explored, so we'll see if that gives them some things to work with going into the prize round.
I got it. You know, one of the greatest things, too, is the continuance of our graphic display. And they saw the sector scored, and you see that in that lower right-hand corner. There's a cube. So, again, this is a singular course, but it has cave, tunnel, and urban all combined into one, so you can kind of see those elements start to pop up.
Yeah, and I totally love that. It gives people a little bit more context of how big this is and how much we've seen so far, which isn't a whole lot.
You know, one of the other things that Kevin brought up were the people in the pit crew, and that is his team, and a lot of those are university students from the University of the Channel Islands. I mean, it's got to be such an incredible experience to have university students come out and be a part of a DARPA challenge like this.
Absolutely. This is one of my favorite parts of this team, is that they are really focused on bringing in kids, like middle schoolers, right?
Yeah.
I mean, they've got
even middle schoolers
all
as well.
ages, and they're really using this as an education. I mean, they have built most of their own robots themselves, right? And so that's a really impressive stage for them to be on here and competing with all of these other teams and doing well. So
and, yeah, right alongside some of the leading researchers in the world. And I think some of those, they even purchased the chassis off of Craigslist. So incredible. And it just goes to show again, what an incredible opportunity for the Subterranean Challenge. It's all about that open source. So if you want to join in on that competition too, well, we've got the virtual test bed. That's where you can take part. Now let's get into our next team. Who is up next? Well, it's Team Robotica. They've got those UGVs and the tracked UGVs, so you're not going to be seeing too much up in the air for this team, but Let's figure out what happened in their second run. And of course, we're going to send it back on over to Scott to walk you through it.
Team Robotica has completed its second run. František Brabec is back with us here. And tell me a little bit about what you were trying to achieve a little bit differently than day one.
So, yesterday was our first attempt. We were not really trying to run our normal, competitor effort. We were trying to get a lay of the land, not take any undue risks because, we only have 2 robots, and if we break them, in the preliminary rounds, then we have nothing to compete with. So yesterday we just used one of the robots just to drive in, establish certain parameters, tune our algorithms, and get out, and we managed to, score a point that was necessarily like a goal to maximize the points. Overnight we were able to use the information we got to tweak our system, and as you have noticed, the robots were starting much more reasonably this time around. So we sort of solved that problem, and today it was meant to be sort of a dry run for the competitor round, for the prize round tomorrow. So today we were trying a little, do something a little more closer to what we're actually going to do tomorrow. In terms of, running both robots, in terms of, trying to see, how many artifacts we can see and report. And to that end, we did launch the bigger robot, Klobak, first, and sort of let it explore as far as it feels like. Our robots are maybe a little more autonomous than other teams in terms of, we don't try or we don't expect to maintain communication too far into the cave or the space. So, there is no like a remote control or anything like that. So, once they are launched, we sort of let them run. So it was a clawback, it went off. Then we brought the other one. Unfortunately, we are having some hardware issue there, so we hope to get the parts we need tonight. But today, the motion wasn't really where it should be, and so it got stuck halfway down the ramp, and that's where it stayed.
Sure. Well, let's go ahead and look at the events of interest here, and we'll be able to see some of that. You guys got Klobak off very quickly here today, went right down the center of the ramp. And really, did you change anything about the way that it was navigating today?
So the overall approach is always the same. We try to follow either the left wall or the right wall. That's up to the operator to choose just before the run. And that's what we did. I believe the first run was to follow the right wall.
And then it came back, and you were able to make an adjustment in about 5 minutes in.
Yeah, and we haven't analyzed what it saw just yet, but it seems that it saw something in there, and as a result decided to come back. There are certain conditions for when the robot decides to come back as opposed to pursue something further. Given that we don't necessarily maintain communication deep into the mine, if we want to receive the results or the scores or the artifacts, we need the robot to be able to come back and report within the Wi-Fi distance. So that's why being able to come back is important to us, and that's why if there is a problem, it errs on the side of coming back rather than pursuing something further.
Okay, so here it got into the urban area and then made the left turn and didn't really go past this area. Do you see anything regarding the navigation that sticks out to you?
That would be for the team to look at and analyze what might have happened. There were quite a few things we learned from our run yesterday. So, some distance was too close, some parameter wasn't quite where it needed to be for the robot to decide to pursue this path further. We'll have to look at it and see later today.
Okay, and this was fairly standard in the way that in this case it got stuck, but there were a couple of times when it looked like it was circling around a bit. At that point, Skitty came in, and this didn't really, I think you were talking about it, right? There was a part issue with a hardware issue?
One of the motors doesn't seem to work correctly. We need to get some parts, hopefully in the mail today. And so I think it was having a hard time to just go through the terrain, and it got sort of stuck at some point. And then when the other robot, Klobak, started coming back, there was some interaction between the two of them in a narrow passage. It got resolved,
Right.
but I think we spent a good amount of time for the robot to sort of circle around and try to find a way through the gap.
Just real quick then, if you're getting a part in the mail, then you knew this might be a problem then, like yesterday or the day before, right?
That's right, yeah. We established that during, even before the initial meeting here, so we knew something was wrong. At some point we determined, what parts we need, and we placed an order, and it's supposed to come here. I mean, it was weekend, right, when we
Right.
So it just takes until, I guess, Wednesday to get the part, and hopefully it's going to fix it, and we'll be able to drive the smaller robots as well as the first one.
Okay, well, we'll look forward to seeing what you guys are able to accomplish in the prize round. Team Robotica, there is the scorecard with that one artifact, a couple of sectors explored, a lot to work on, but I think we'll see if you guys can bring it all together for that prize round.
Yep.
Thank you.
Thank you so much.
Exploration still very key as they head into the prize round. That's definitely something to pay attention to, but there's also an added element of difficulty that we haven't talked a ton about through our broadcast, and that's that this course is potentially shifting and changing, whether it's the artifact locations or the course itself.
Yeah, absolutely. And I think even in the first two teams that you've seen, the artifacts aren't the same as day one, if you remember. They definitely move those around, but there's other things that they're doing in there too.
Oh yeah, it's all about reality, right? And changing that course as much as possible. Now, one of the other things that was brought up was, this is a custom hardware. This team builds their systems by hand and just by themselves.
Absolutely, and it changes the supply chain, right? And so you are responsible for kind of everything on your own robot. You can't call a manufacturer and say, hey, this isn't working, can you send me out a spare? That just doesn't happen. They have to be smart about what spares they bring, what they have already in stock, what they're doing, and then the unexpected always happens. I have to say, from packing for robots myself, it is almost worse than packing for a toddler. So.
That makes sense. There's more parts.
Exactly.
All right, well, let's head on into our next team. This is going to be Team Cerberus, and you can see the cross-collaboration between borders. Fantastic to see this team able to put one heck of a roster together. They've got the legged UGVs, multi-rotors, and wheeled systems in place. And we got Scott Walker walking us through. That's ironic. Scott Walker walking us through run number 2.
Team Cerberus back in action for their second and final preliminary round. Marco Transato is back here with us. And overall, how did you decide to spend your time today?
So today we wanted to deploy the main legged robots across the course and let them explore different sections. And then the idea was to later on send in a scout in a more narrow area. Unfortunately, we had a few technical issues, so we couldn't deploy all the legged robots and also the drone. But so we managed to deploy 3 animals in the course and just like mobile antenna robots to support teleoperation.
Okay, so you got 3 of your 4 animals out there. Let's go ahead and just look at some of the events of interest, and we'll start here. You guys got some really good early action, and then we'll see first getting into that cave subdomain. And what was interesting here is you wanted to get you wanted to get all 4 in. You got 3 of this particular type in, correct?
That is correct, yeah.
Okay. And what were you able to accomplish here in this cave section?
So I think we could explore 2 branches and then reach like a big opening. But then today we wanted to be a bit more conservative, so we didn't let the robot go out of communication range because tomorrow is a big event. So.
Okay, we were able to see a couple of times when at decision points the robots actually paused a lot, and that was because of the trying to make sure that they stayed in communication range?
That's correct, so we didn't want to let them go for today.
All told, here's a second bot, and this is going to go into that tunnel section. What was interesting was in the preliminary round 1 in tunnel, you guys had a problem with with one of those animals going down. It looked as if today that same machine was able to traverse the tunnel section a little bit better. Did you notice that?
Yeah, so actually yesterday we reached this intersection point between the urban and tunnel environments, and the 1 foot got stuck in the railway, so that's why yesterday the robot fell.
Okay.
But overall, the robots are able to navigate these type of environments.
Did you make an adjustment to be able to change the traversability or some of the ways that it measures that?
No, we are pretty happy with what we had yesterday, so we did not touch this.
Okay, and you can see here it was dancing around the rails where it had some issues yesterday, but was certainly able to successfully navigate that today. Now, one of the things about scoring here, early on you guys had early success, a few false positives it looks like it was earlier. Anything that you think about there? Look at this, a wonderful job of showing how it's able to traverse a lot of really interesting terrain.
Yeah, that is true. About the false positive, I have to admit it's not so easy also by human eyes to understand if the objects that are reported from the robots are actually what we are looking for or not.
Right.
So that's the main cause of these false positives.
Got it. We still have to remember the humans are a part of this. Now, this is the urban sector. As we were looking at it, and again, we talked about some of the times when those robots were pausing a bit, but at least you were able to get into each of the 3 subdomains. What will that help you do tomorrow?
I think we want to replicate this strategy, but once we have all the robots in the course, we want to let them explore by themselves and fully unleash their autonomous capabilities.
Okay, without the drones being deployed thus far, how will you be able to use them in the prize round?
We would like to deploy the drones in the final rounds, either as scouts at the very beginning of the mission or towards the end to explore an area where the legged robots did not go.
Well, we'll see what Team Cerberus is able to do in that prize round. A lot of discovery early on in these first preliminary rounds. Here is the scorecard. 6 successful artifacts scored with a 40% success rate. A lot of, again, the false positives, but 12 sectors of the 28, and that certainly will be something you guys will be interested in. Let's send it back to you.
Thank you very much.
So a nice run from Team Cerberus. And another element we haven't quite discussed a lot, we brought it up with Team Coordinator Robotics in regards to their pit crew, but the role of human supervisor, the one that's sitting at the computer, how does that workflow kind of take place while they're in the staging area?
Yeah, so it really depends per team, but for Team Cerberus that we were talking here, they are pretty involved. As you heard from the interview, there's a lot of deciding where to go, so what waypoints they're going to make, which sectors each robot is going to explore. And so as they are seeing kind of what's going on with that map and how they're developing, how the exploration is going, they're deciding who goes in next. We talked a little bit about how the UAVs didn't get deployed today, but they might be deployed tomorrow. And finally, the detection of objects. And so even Coordinator Robotics talked about the same thing. We got 0-0 on this object. We know that isn't right. We know that the object's there. What is it? So there's a decent amount of kind of human decision making then on, does this seem right? Does this pass a sniff test of, should I actually submit this to DARPA?
Yeah, and if you're just joining us again, they are searching for artifacts, and there's quite a range of artifacts that they're trying to identify. We saw kind of a helmet potentially taking place. I mean, how much of a challenge is it to identify one from the other? Because not only do they have to localize them, but they have to correctly identify the classification of artifact.
Absolutely. A lot of them are using machine learning, and so they have to train for every single object that they expect to see. And there is a change in objects from today to the final round, and so there's even that they have to keep in consideration. So there's a lot of things that either the human and or the robot has to kind of keep study in their head.
Yeah, keep learning. Well, it's time for us to keep learning because it's time for a robot technology segment, and today's topic is all about networking. Here you go.
Traditional solutions have difficulty traveling large distances underground and maintaining connectivity due to complex layouts, bends, dead ends, multiple levels, and interference from other radio frequency sources. Teams have used diverse networking solutions such as Wi-Fi, Bluetooth, LoRa, breadcrumbs, mesh networks, and tethered connections to tackle the networking challenges of operating underground. teams have designed autonomy algorithms to extend the range of their network connectivity by autonomously deploying communication breadcrumbs, relaying information with other robots within communications range, and allowing robots to explore outside of communications range for a period before automatically returning to home to re-establish connectivity.
Culmination of all my background, right? I mean, I've worked a lot within the P&T area, and so obviously a lot of what I've been interested in is inertial sensors combined with the communication that's required to enable navigation in unmanned spaces. Right? If I have one vehicle, I think that's a simple comm relay. It's one-on-one operator to that particular vehicle. The minute I have a second vehicle in there, again, I start to think about the networking aspect, because now I've got multiple communication links that I need to kind of close. A lot of that's going to go down into what is the specifics of that environment, right? What's the moisture content of that environment? What are the makeup, the chemical soil makeup, right? Again, if I have a lot of conductivity in there, that's going to absolutely cause me a significant problem at the elevated frequencies. And so maybe I need to switch to lower frequencies. What are the opportunity spaces to generate signals of interest in different frequency bands? So I think you'll see a wide array of opportunities and potential solutions that are required. And then you have the whole separate challenge of, okay, I have to constrain this to some platform, right? And what is the power management, the computational management? And then again, typically networking and data out is always one of the more challenging and power hungry opportunities, or drains on the system. How do we handle that appropriately? I think in the end, the solution becomes an ensemble of solutions, right? So what do I have for my low data rate example, that signs of life information that gets transmitted out, versus my high data rate, maybe video feeds. We'd like all that information. And again, the terrain, the obstacles, the environment's going to dictate what can get through and what can't get through.
Information game seems to be at the forefront of networking. I mean, how do you even go about exploring these unknown environments?
I mean, with the limited information that you're going to get, because of all of the challenges that they just talked about with the networking, there's a lot of things that aren't solved. It's very hard to get the situational awareness to know where you are. I mean, if you imagine that you and a friend are going and you're trying to use walkie-talkies and they only sometimes work, how do you know that you've explored anything? And it's the same thing with the robots. It's very difficult to know enough about what's going on to really be efficient with your exploration unless you have that optimal solution.
Oh yeah, so information gain critical. Let's see how our next team does in regards to that information gain. Here is Team Marble. You can see their UGVs, legged UGVs as well. And they're going to use a couple multi-rotors. Let's see if they can get those launched in their second run in the preliminary round. Again, over to Scott Walker with our wrap-up.
Team Marble certainly got the ball rolling here on day 2 of the preliminary rounds. Harrell Biggie joins me here, part of the team that is making sure that everything works well. And so far, it looked like there were a couple of areas, particularly with the way that you were scoring artifacts and your success rate, that things did go pretty well on the day. How do you assess it?
Yeah, it looked very good from my perspective. We added a front-person view for our operator, as well as some deconfliction with cell phones. And that let us confirm the reports the robots were giving, and we had a 1 or 2 false positives, and beyond that, everything we reported was accurate.
When you say a front view, what do you mean by that?
With our spots, our human supervisor gets real-time footage from the robot that he can monitor in case our automated systems miss anything.
Interesting. Well, let's go ahead and look at some of the events of interest, and it really starts with the traversability of with one of your spot robots, particularly once it gets into the cave area. We're going to see some really difficult terrain, and yet it was able to handle it despite a few stumbles. Is that what you guys see in testing as well?
Yeah, that's very similar to what we've seen in testing. Our spots do really well on rough terrain. Our planner is able to get it out of there as well generally. Hopefully that happened during this run.
It did happen. I mean, you guys are in Boulder. That's mountain country. Do you guys test outside too?
We've tested at some local parks that have some of that similar terrain to inside caves, just outdoors. And we're also tested pretty regularly in a local mine, gold mine.
Okay, interestingly, a lot of the points of interest came in the urban section, and we can see here with the spot working with the wheeled, one of your wheeled robots, and then something surprising. You may not have seen this, but in just a quick second, that is a dynamic obstacle that'll really close off that way for the robot to interact. How do you deal with that?
So our planner is capable of handling those types of dynamic obstacles. It's a graph-based planner, and we actually close off the graph so the robot knows it can't go back there, and it's able to continue planning, and if it has any other path home, it will find it home.
Well, at this point, it didn't really start to look for a path home and looked for some other areas in this urban sector. For you guys got, at this point, it was 13 of 28 sectors explored. How do you feel about the way that your robots were exploring the terrain?
We felt pretty good. We did unfortunately have one of our spots that was out of commission, which probably would have gotten us a few more sectors. We're going to look at why that happened and hopefully resolve it for tomorrow.
Last thing, what is left to do? It's only the prize round. What are you going to look to do over the evening?
For us, it's really just investigating a few reliability issues on our robot, making sure everything is buttoned up and ready for tomorrow. We are not planning to do any significant changes beyond that.
Okay, we'll look to see what Team Marble is able to do. A pretty good scorecard for this team as they head into the prize round.
It was really cool to see that dynamic obstacle just drop down from the ceiling like that, another one of those hard elements. But there's something that I'm curious if you can answer for me. So on the top of their legged UGVs, it looks like there's some LED indicators, some lights going on. What is that, and what are the colors we see?
So we actually got a little bit of information from Team Marble, which I thought was very cool. So they've taken the time to make visual indication of the robot's software state on their robot through these LEDs. And so they have a whole cue card of what are the lights, what are they doing, what are the colors, what does that mean? It's actually really important for human-robot interaction. These aren't really going to be around humans so much, but if they were to just look at a robot and kind of know what it's doing is a very important thing.
Yeah, so you kind of see those different, whether it's flashing or glittering, you've got all sorts of different color systems too, so it kind of gives you cues. So as you continue through our coverage, that's something for you to look for back at home. And it's already time to move on. We're going to Cyro Data 61. You can see their robot roster, this team all the way from Australia. And I'm going to send it on over to Scott Walker to check out run number 2 for the Australians.
Team Cyro had one of the more eventful rounds that we have seen thus far. Brendan Tidd is with us, who coordinated the effort today. And I say this, your BIAs were powerful, multiple drones deployed, and it was perfect detection for the artifacts. All that said, how did you see the run?
It was a far more stressful run than yesterday. There was a lot more on-the-fly management, pardon the pun. But one of our robots disappeared off the map very early, and we never recovered it. So that adds to the stress. But once you lose a robot, you go hunting for it. You go looking for it, going looking for its data. But also, conscious of the mission, trying to find things and, report back successfully.
Well, sadly, things that are stressful for you are eventful for us. So let's go ahead and take a look at the events of interest, and we'll start here. This is actually in urban. This is the robot that eventually you lost a little bit of track of. But in the urban setting, by this time, it had already deployed actually triggered one of the dynamic obstacles, correct?
That's correct. Well, as far as I'm aware, I retraced its steps and I saw a wall blocking me, so yeah, that's correct.
Well, and this is the fog that's kind of obscuring some of the things that happened. That's the dynamic obstacle that got triggered. Nice. How did that affect the rest of the run?
Originally, I thought it would be hard to track its data. So the issue was I lost comms to that guy straight away, and if I hadn't, it wouldn't have mattered at all. But because I had to go and hunt it down, I had to find another way around.
Well, some of the communication there, you saw one of 3 communication nodes you dropped. This is in cave. I believe that's rat in the cave, and it got really interesting there. How do you find the traversability that's showing right now?
Yeah, it's actually quite nice in that image. It's probably looks worse on my screen. Yeah, it wasn't too bad to get it to this location. You know, just a little bit of nudging here and there.
Well, and then getting it past this location became interesting. Overall, it looked like it was flowing well, but going around that corner at that point, it had a little bit of trouble. What did you see from that perspective?
Yeah, exactly. I think particularly once the drone took off, a couple of things happened. One, I got lost in the dust of the drone,
Right.
which kind of inhibits the movement. And two, my attempts to control that robot were inhibited. So I'm not sure if that robot's in perfect health, but we have to investigate.
Okay, well, we'll get back to the drone launch in the cave. Meanwhile, in urban, this is your other BIA 5, which is Bear, and it was able to get in some very tight spots.
Yeah, we've got an amazing gaps behavior now that allows it to do that. It's just very focused and controlled.
Interesting. Looks like it picked up a point there as well. How close to real time are you reporting some of these artifacts?
Somewhat. So I report as I go, but obviously if my focus is taken away by manually intervening, you know, there can be delay up to 5-10 minutes.
Right. Okay. So at this point, after having trouble, the drone launches from RAT. What precipitated that?
Yeah, so the idea with the drone is try and find somewhere with a high height, a high ceiling, and hope that there's an artifact up there. Ideally, those drones are really good in bigger open spaces. So I was hoping that this section would open up, but that wasn't the case.
Well, this is what you were saying. Obviously, the drone became the obscurant, right?
Right, exactly. So it's quite dusty, and that impeded this robot's ability to get out.
Well, we saw that for quite a little bit of time there.
Yeah.
As it was trying to get, you're trying to get it to retrace its steps or find another way out?
I tried several things, including retracing its steps, and this was me teleoping, I believe. I actually had communications to it. The fact that I couldn't teleop well indicates that there might be some issue with the motors or some health of the robot.
Okay, so we'll go back to the urban setting here, and this became one of the more dramatic parts of the day. Right. So at this point, it's finding a way out, and sometimes the way out is through, but it didn't seem like it knew that. At some point then, this drone launches. What precipitated that?
Yeah, so perhaps my situational awareness was off. I thought I was in the clear. I thought I had a high ceiling there. So that was the process of launching that drone. Unsure what happens next.
Okay, so this is gonna be interesting because it launches well, and then we're going to see, because of the rotors, we're gonna see some things flying.
Nice.
And then once we see that, you'll see the drone go down.
Whoa. Okay. That old chestnut. Right.
Yeah, so honestly, it looked like a ream of paper or something like that ends up being what caused it to go down. Meanwhile, that is your other drone. It got caught up in the tunnel areas as well. So with your reaction, what do you see from those two things?
Yeah, so drones pick up stuff. Things that caught in the props, there's not much you can do about it. Try and avoid launching in those areas. That would always kill us all of the time. The only thing I could do is make sure it's a clear area, and that obviously was quite cluttered.
But all that said, 100% for detection today and a lot of ground covered. How do you feel going into the prize round?
Yeah, very good. So we'll have a look at some of those issues that we had and sort of reevaluate, some of that strategy, particularly, the cluttered areas, drone launch. But again, we've kind of got 2 for 2 spots falling on those tracks, so we've got to really try and figure out what to do about that area.
Well, we'll look at the scorecard now for Team Cyro going into the prize round. A very good day for them. 8 for 8 on 11 sectors out of 28 explored. Good day for Cyro in day 2.
Some of the things they're going to have to work out. How in the world they repaired that UAV? My goodness, that thing went down, and it went down hard. But one of the things this team does exceptionally is their mapping. Why?
Absolutely. They have focused quite a bit on their simultaneous localization and mapping, SLAM, we like to call it in the robotics world. And so they look very hard at their local SLAM on each of their robots. They put that together into basically a global map. And that global map, they do it so well that it's really helping them. That's what they get that 100% report success from, is being able to localize those objects.
Well, we'll see. Hopefully into the prize round they can find a little bit more space to launch that UAV, because I don't know, Well, there's robots being destroyed. So let's see if any robots get destroyed in this next one. Our team, CTU Krasnorlab, they've got the UAVs, so maybe one of those goes down. We'll get a chance to check it out with our guy, Scott Walker. How'd their second run go?
CTU Krasnorlab back in action after their second round in the preliminaries, and Wojtek Slansky is back with me. And tell me a little bit, because it looked as if you got a lot of activity aerially with the drones. You used a large number in your fleet. How did you think that the run went overall?
I was expecting that this run will be like a little bit better than this one, than the last one. I think that we did well, but I'm not sure if all the robots are like in good condition after this run. So I'm a little bit nervous that if they are like all okay.
Okay, well, we'll show you some video. It might make you more nervous, but we'll go ahead and see some of the events of interest early. And this was the first robot, one of the spots that went in, and then just kind of looked around and came right back out. What happened there?
We find out that again that the calibration to gate is not fine, so we recalibrated. And we tried again to recalibrate it, but there was some issue with odometry of the spot.
Okay.
So we have to solve that.
So that led to what I thought might happen earlier for some teams, which is leading with a drone here. And this drone got down into the entry and then actually didn't make it that far. What did you notice about this run?
Oh yeah, as I said last time, the drone's like exploring well. I was hoping that there will be like you know, this environment is not drone friendly.
Okay.
Like it's really small and so on. So.
Well, you can see it's going to look at this backpack there on the left, and then just kind of loses stability.
Oh.
That surprised you. Okay, all right. We'll move on.
This is, I think, the worst thing.
Okay, yeah. And so this is one of your tracked vehicles in the cave situation, and it looked like it got a little stuck. Were you aware of it at the time?
What?
Were you aware at the time that it got stuck?
Yeah, I've seen that the robot is stuck there for a lot of time. So I'm trying to like unstuck him manually, and maybe that's the reason why the robot flips. Or if he flips, I'm not sure.
Okay. And again, we're back with one of your Boston Dynamics spot robots there into the tunnel situation. What happened here? Looks like at some point it kind of sticks as well. There we go, again along the tracks. And that's been, well, actually, no, it actually does get through the tracks and move well as it's going along. Were you happy with the performance of those vehicles?
Yeah, if they will start, then it is like a really good platform, but there are some troubles to like boot it well. So sometimes it's hard to get the spot inside.
Right, but so far moving decently through what had been a difficult spot for some of those legged robots. In terms of your total exploration, do you feel like you saw enough of the course today?
No, like as I can see, only 5 from 28. It's not enough. I was like hoping for much better results, but
okay.
So let's see what we will do tomorrow. I hope that it will be much better.
Okay, well, this is one of the wheeled vehicles getting through the urban area. In terms of some of the smaller vehicles, were they able to navigate and get you into places that you wouldn't have seen otherwise? Yeah, were some of the vehicles of this size able to explore well, as we're getting a little bit of noise here, but did that get successful? Obviously, well, actually, let's go ahead and move to the drone now, because again, this, why launch the second drone here?
Oh, why?
Yes.
Oh, so why? Because we want to like explore them as much as possible. And oh,
Okay,
it was
so
close.
yeah, it was close, but happily, it was navigating through, and you were able to get again. You only saw 5 sectors, early, but that was 16 minutes in. So you did much better later, being able to explore more of it. So with all of that, you got to see, maybe about half the course or so.
It's not so bad.
It's not so bad. Okay. What do you need to fix or adjust tonight for tomorrow's prize round?
I think that I think that the most needed thing is to drill the start and boot all the robots and be able to send all the robots at the course, good frame and with all the things running. Like one of the spots doesn't not good, but the drivers was not running like the basic stuff from on the spot. So that's I think that's some complicated. We just think that all the spots can be there today.
Well, you'll have twice the time. You'll have an hour in that final prize run.
So
Let's go ahead and look at your scorecard there. As CTU Krasnor Lab, 20% success rate on your scoring. Explored, you actually used all your attempts and got 12 out of the 28 sectors explored. Good luck in the prize round coming up tomorrow. Thank you.
One of the best parts of these post-run interviews is seeing team members watch the footage of their systems going down and just kind of recognizing. I know there was a part that UAV went over the top of a UGV and you could see the expression, but I know this team struggled a little bit in the staging area. Maybe some calibration issues?
Yeah, so one of the things that they have to deal with that the virtual teams didn't really have to is that there's a coordinate frame in all of our maps, and that coordinate frame has an origin point, a 0, 0, 0, and then everything that you get reported has to be with respect to that coordinate frame. And so you have to make your robots get into that coordinate frame and know that, and virtually you just kind of give them that information. In systems, they have these April tags around and doing that. They also talked about just getting those robots booted up. Man, I feel for him. That's very frustrating. So yeah, those challenges don't exist in virtual.
Yeah, no, definitely not. But in systems, that is definitely the case. It's time for another segment, Why It Matters. We always take a look back and remember exactly why the Sub-T Challenge matters so much, building these systems to better aid and support warfighters and first responders. So now we're going to get to hear from John Spencer of the Modern War Institute. He is our Sub-T stakeholder.
So I'm John Spencer. I'm the chair of urban warfare studies at the Modern War Institute, which is a research center at the United States Military Academy. So urban warfare is the most challenging environment that a military could ever conduct an operation, whether that's humanitarian assistance and disaster response and major storms, as we see climate change impacting urban areas around the world, all the way to high intensity urban combat against an enemy defending urban terrain. It's the most difficult terrain because of the complexity of the physical terrain, but also the fact that it's the one environment where there's going to be a lot of people that both need protection and in some cases need rescue. And lastly, the infrastructure, right? So the urban environment is going to have this complex infrastructure that supports the human life that's there. So on every aspect, just understanding the environment, it's the most challenging thing for any military in the world. Robotics in general are helping revolutionize the way we approach operations, especially in urban terrain, because of the risk. Robotics gives you the chance to reduce that risk for the soldier and in some aspects for the civilians. All of our technology that we currently have fielded doesn't help us. You send a soldier or first responder down underground, most of the equipment that they would normally rely on isn't going to work. Your radio communications, your GPS systems that rely on satellites, it is such a foreign environment and the risk goes so high that it's almost like this no-go area. And that's what we see in warfare. It presents the challenges. And that's why I think the Sub-T Challenge is literally going to revolutionize our approach to this environment that we've almost not forgotten about, but really haven't presented any solutions that help us. some people, if they hear the word robotics, they think about remote control. And we have been investing in some of that above ground in urban operations. You basically sending a robot forward of us, and it relies on line of sight. But once you enter the underground, robotics need an immense amount of autonomy, one, to reduce the risk to the soldier, but also do the things that we can't, which is see underground. That ability to gain situational awareness of what environment we're entering is so critical. And what the robot does for us is it may be able to go into environments that we just can't get into based on the size, or that we have to have awareness of before we put more soldiers at risk, or understand that how fast we need this information. Time is so critical. So being able to insert a robot and to rapidly map the underground will revolutionize how we do search and rescue and how we do military operations.
Reduce the risk, that's the objective. And we've got only 2 more teams to go on today's coverage. Team CoStar is our next up, and you can see that robot roster getting pretty deep. What will they have in their second run? That's the question. So we'll head on over to Scott to give us a lowdown.
The most eventful runs on day 1 came from Team CoStar. On day 2, looking for a little less drama and a little more exploration, Benjamin Morrell joins us again. And did you think that you got that? Because it seemed like there was a lot of instances where you guys had coordination without collision, if that makes sense.
Yeah, so let's say we learned a lot from the run yesterday, and it's really a testament to our incredible team, both here who are allowed on site, here where we're based at the University of Louisville, but also remotely around the world, that within or under 24 hours, we're able to analyze the data, identify the issues, work out solutions, test those solutions, and integrate those solutions for today. And so it's pretty incredible what the team was able to do. A lot of things that were kind of low-hanging fruit, so to speak, that was a clear issue that was a simple fix, but a lot of other things that were small little tweaks or issues in our pipeline that the team was able to resolve on every aspect of the system, from how we detect the artifacts, how we send the robots around, how we do operations, how we localize, how we traverse. All different systems had little fixes that they had just between the last run and this run, and that really was allowing us to show what the team's capable of.
Well, let's go ahead and show some of the events of interest to illustrate exactly what was happening there. And we'll start with the cave subdomain, and it looked as if you guys were using the spot robots, the leg robots, to be the primary node, communication node droppers. Is that a change for you?
We want all robots to carry communication nodes because we don't know what environment they're going to face and if they're going to be going out of communications. And so all of them, we want them to carry nodes so they themselves can stay in communication with the base station. The Huskies, the wheeled robots, carry more nodes, so in certain environments they can drop those to regain communications. But in this case, each robot needs to carry its own based on the nature of exploration.
Right, and we're able to see, did you find that the networking was very good today?
The networking was much better today. You might have seen we also deployed a communications node down the tunnel by hand, and that seemed to help us out with our communications.
There we go, there's that, nodes dropped in action.
Exactly. So some of the material of the walls that we see is a little bit unknown, and so that changes the nature of communications, and a lot of improvements there, some really interesting dropping, so generally good. Spot 4 explored out of communications for a while, but it was able to come back and we were able to get information back from it.
Very good. Well, we're able to see at this point now a little bit more as they're crossing one of the interesting points here with that bridge. And it really led to the ability, even though you use fewer vehicles today, there were still places where your vehicles did find each other, but were able to, in a sense, deconflict and find new ways around. Is that correct?
That's right, just a little bit less traffic going on, but also, so that's one thing, changing our operations with less robots that suit this environment. But the second thing was some of the algorithm side of things to identify that you're near to another robot, to wait.
Like in this situation right here.
Prioritize one to allow to go away. So that was one of the fixes that the team had.
Well, and it seemed to work out very well, because as we see there in the cave situation, well, actually, let's go ahead into the tunnel, because it looked like one of your wheeled Huskies got a little bit stuck, and the Spot was able to navigate around it with pretty much ease.
It's good to see. The Spot is very nimble and agile, so that's where it's able to get around. I think in that situation, it just identified the Husky as an obstacle and went around it. These railway tracks are a real killer for the wheeled platforms unless you have some really large wheels, like Team Explorer, for instance. So Huskies that's a particular challenge for Husky. It can get off it sometimes, but looks like it got in a rough situation. But Spot is well suited to these environments.
Well, but even then, sometimes in the tunnels, we've seen some of these legged robots not handle a tunnel well. Yours did today. This is another example where they both meet in a situation in the cave and then are able to not only deconflict, but then follow each other to another domain.
That's right. So when they're not colliding, the intention is that they collaborate in how they're exploring. And so they may be going in a similar area for a certain period, but their goal of where they're going to explore is different. So if they deconflict, then they should be going out to explore different areas after they've been together.
This fence in the urban area looked like it was a new obstacle, but it was handled well. Any particular reason why you think that was not an issue for your robot?
Yeah, we've seen challenges with similar types of fences in the past. But I think with our LiDAR, we're able to pick it up with the mapping. As long as we catch a few points on it, we can identify that as an obstacle that we may want to avoid.
All told, early on, it looked like you guys had a very high percentage of artifacts detected. It looked like maybe at the end you made a rush to get some reports out there. How are you happy with that? Because it looked like with all that exploration, you were able to detect well.
Yeah, it'll be interesting how it changes with a 60-minute run where we have more time allocation to go through the reports. There's no point really leaving unused artifact reports. The percentage doesn't matter too much in this competition. So that's why we're using it more, but the way we have it for the operator's time is we prioritize the highest likelihood artifact. So we have a likelihood score, and then that's where it's higher percentage at the start because they're very obvious artifacts, and then a little bit lower likelihood as we go to the more challenging ones.
Last thing, given the encouraging progress that was made, how do you feel going into the prize round as we see your score here?
I think a bit more confident than yesterday, let's say that. Again, I think our team's got fairly high standards, so we'll see how the data is there. There's things that we can tweak and improve, but I think generally feeling kind of confident that we'll be able to at least show what our team's capable of. And that's the real goal, to showcase all the great work that our team all around the world has been putting in to make this system work. And I think I'm confident we're going to be able to show that.
Well, after day 2, Team CoStar, the standard was quite high. 11 artifacts found and 17 sectors explored going into the prize round.
So 11 points on the board for Team CoStar, and just a reminder, those don't have any necessarily impact into the prize round, the final round for these systems competitions, but it shows a huge progression for this team from their first run to their second run, and a ton of work being done and testing.
Absolutely. You can definitely see from what they were talking about there, iteration, test, build, go, cycle with everything, which is awesome. I mean, the agile software development lifecycle was what this competition was built around, and so they're doing exactly what the Subterranean Challenge wants them to do. So they learned something yesterday, they looked at it, they analyzed it, they came up with some solutions, put them in, tested them, and came back and got a great score.
Yeah, well, they had a lot of help too. You mentioned, you know, they had the team here and then also the team over at the University of Louisville. That's something else.
Remotely.
And
so,
remotely.
Yeah.
So they have a few. The pit crew is expanded for Team CoStar. All right, let's head on into our last team of the day. This is Team Explorer. They've got the UAV, 7 of them, so they're very aerial. This team is out of Carnegie Mellon and Oregon State. Yet again, Scott Walker has their second run. Let's take a look.
The key for Team Explorer on day 1 was to explore. It's in their name. But today, Sebastian Shearer, you guys put up a number of points, and you did so with multiple drones launched, with great scoring, and really with no big issues or crashes. What are your takeaways from day 2?
I didn't know that we didn't crash, but I'm glad we didn't. I'm glad to hear that. So I think our robots worked as expected. It was a little harder than we planned. It seemed like there was some fog that we saw coming out. But overall, I think we're very happy with the way the system performed.
Okay, well, let's go ahead and look at some of those events of interest. And we're going to start in the urban area, and we see one of, well, yeah, exactly. A little bit of trouble there. It didn't crash, though, as we said, right? So that ability to be able to get up, try to force your way in, and then find another way out. What's in your algorithm that allows them to do that?
Yes, that's so we have some way for the robots to detect. You know, they're a little optimistic in the way they can move, and then if they really get into dangerous situation, they'll try to recover.
And in this case, they got to a situation where they said, all right, let's see what we have overhead. Were you able to understand how much vertical clearance you had here?
No, so actually this is fully automatic. The robots, when they think there's enough space, the drone launches automatically and just goes out. We don't want to give our operator too much workload.
Well, and as you can see, they found a space with a lot of air because there was a lot of flight here, and also it looked like the ability to get through doors that weren't much larger than their total clearance.
Yes, yeah, that's something we've been working on a lot, that basically the drone aligns with the door and then tries to shoot through. Yeah, you can, I don't know if you'll see it in this shot, but yeah, the drones will basically try to align and then go through.
And we did see that. There is one of those trying to figure out, okay, how much space do I have through this door, and can I get through? And they were able to do that to some great success early on.
Cool.
Yeah, down this. Well,
that's what we've been practicing. It's awesome to see this in something that we've never seen
It's
before.
been fun to watch you guys smile here when you're seeing all this work pay off. Now, a little bit later, now watch what comes down here, the dynamic obstacle, and this is triggered then by that drone. It did have an effect later. As
interesting.
Well. Okay, and you guys were unaware of that then?
No, we didn't. I mean, I didn't know. Maybe our operator.
Okay, but then behind, watch. You're going to see one of the drones. You got one of your wheel drones goes right by, because all of a sudden, that's not a way they can traverse again. All that said, we're going to continue to see one of the wheeled vehicles getting through that urban area. A lot of time was spent, at least from what we saw in urban. And you can see 13 to 28 sectors explored, and many of those in that urban area. And you can see here a couple of communication nodes as well. What was the priority to get those nodes in for networking?
Yes, so the robots automatically deploy these nodes as the robot goes by, and it looks like it built up a good network.
And you can see one of these wheeled vehicles, the UGVs, saw that dynamic obstacle and then left. This is the drone actually landing after a little bit of flight there for. Number 7 was the one that was that the marsupial, or was that the one
that was launched at the staging area, so it tried to get back and probably couldn't make it past the dynamic obstacle. And then when it can't do that, it tries to find an alternate way.
So traversability in tunnels has been an issue for a number of teams, but overall, how do you think you were able to navigate some of those issues today?
So it looks like the robot drives pretty well, but there's some fog there that it probably has some trouble with.
That's true. And then again, you can see that dynamic obstacle played a big role in that urban area, but you were able to navigate that.
This is R2? Okay, cool.
Right, and see that. So with all the things that you've just seen here, what's some of the work that you've done over the evening between these two runs that allowed for you to perform like this way today?
We actually didn't change that much. There are a couple of small things that we saw yesterday, but overall, I think this is the kind of thing that we've been practicing.
And you were a couple of vehicles that you wanted to deploy but didn't. Do you have was it just ran out of time?
We ran out of time. Our larger drone would have flown past the start time. We didn't want it to be emergency landed, and the spot takes up a lot of time of the operator, and we just didn't want that.
Okay. Overall, the scorecard is coming up. It was a pretty good run here on this day. 8 points with a lot of success and 13 sectors here, as Team Explorer looks like they will be one of those late starting teams that will be in contention to win this prize round.
You know, we focus so much in on the aerial side for Team Explorer because that's where they're focused in on. I mean, what are some of the risks potentially associated? We've seen some crashes and falls, but what are the other risks for deployment for them?
Well, I mean, obviously they went with a different route and said, okay, I'm going to let my drone decide that it's going to go and be launched. And if you saw that clip, it was right at the same place, just a few feet over, right, from when we had trouble. launching the other one in an earlier clip. And so I think that from this standpoint, understanding the situational awareness, not just above you, but also around you. What are the loose objects that could be part of the environment that now fly into my drone blades and cause a dramatic crash? It's hard to do that. I mean, you obviously have the sensors looking up, but to be able to understand everything around you is going to be difficult too.
Well, and it's also important to note those UAVs, they definitely vary in size as well from team to team. So some of those awfully big to get through some constrained passageways, but that finishes out our systems competition for our second run in the preliminary round. So here is how teams have shaped up just from the second run alone. And you can see the sectors explored. That's a really neat element because you kind of get to see the depth and the area that these teams have been able to get to and map out. Team CoStar up at the top as we head on into our next view, our leaderboard for the systems competition. It's going to be a little bit of the same, and as a reminder, you can start to see those scores add up. Again, these are just for the preliminary round, which have no effect heading into the prize round. You just are learning and gaining so much information to be able to build up to that final day, the big prize. And Cyro Data 61 doing a very solid job. Now, as a reminder, we talked about the virtual competition early on in the day. I also want to bring you back to it because tomorrow it's going to be that final world, World 8, and we're going to be able to find out who the winner is of the virtual competition. Right now, up at the top is Team Dynamo, but there's not a lot of separation between 1, 2, and 3. So that final world, it's going to come down to it, world number 8. And of course, we've got to catch up with Scott Walker to finish off our show. Scott, what are some of your thoughts after seeing our broadcast today?
Well, Cameron, the summary is this. Teams have frayed nerves and certainly a lot of tension here. Robots are dinged up. While these runs, the score doesn't matter, but these runs very much did matter. It's made some of the teams unsure about what they're going to be able to do in the final day. There is anxiousness about getting finished, but not before they put out their best foot in the prize round tomorrow. We're looking forward to it.
Thanks, Scott. And now, Julia, I'm going to send it back to you because we've gotten so many insights and so much learning. But what have we learned heading into that final day?
There has just been so much work that these teams have put into it. I know there's a lot of things that they've done that are similar between the teams. There's a lot of differences in their strategies, but one thing remains the same, that they have put in a tremendous amount of effort. They all have been thinking very deeply about this problem. They have set up their runs, the preliminary runs, both yesterday and today, thinking about what is it that we're going to do on that prize run day. All of the virtual systems, they've been doing what they do. They put all of their controllers and autonomy together to win this whole thing, right? So they're trying to get this all together and doing the right stuff. So it's really exciting to see how that work is going to pay off, and we're going to have just reams and reams of data to look at afterwards and say, hey, what went well, what didn't.
Well, and that's a great point of conversation. As you hear cheers in the background, there's going to be a lot of cheers into tomorrow. So let's take a look at what we will have in terms of our broadcast. This is our rundown for the day. We've got all sorts of stuff happening. So we will be watching not only that final world for the virtual competition, but also that systems prize round. It's going to all come down to our final day of coverage, and we will be bringing it to you live here on Sub TV. It's also important to note that we will be having a roundtable discussion with all of our teams, both the virtual and the systems. The Sub T Summit is going to finish off our night on our final day. That's going to be Friday, 9/24. From myself, Julia, Scott, and the rest of our crew, thanks for joining us today, and we will see you right back here on Sub TV.